So I had a great question, which was, why is the differential of 2 to the power of x equal to log natural 2 to the power of x? Where the heck does this log natural 2 come from, in other words? And it's quite hard to see where this comes from. If you go down the traditional route of trying to prove why this is the case, and why more generally the rule to know is that if you differentiate some exponential function a to the power of x, that you're always going to get log natural a times by a to the power of x. The way we can show that that's the case isn't really obvious, but we can explore that now. So if I had y equaling 2 to the power of x, and we want to know what the gradient is at any point along this curve here. We could start by doing something that's maybe kind of makes sense, because we've got because of the fact that we've got an exponential here, and the fact that we're going to get rid of that power. But it's not entirely obvious to show that what the differential is. So this is quite an important first step, and that's that we could just take natural logs of both sides. So that's what I'm going to do. If I take natural log of y and natural log of 2 to the power of x. And the reason for that being that, of course, this means that I could bring this x to the front. So I can say that log natural y is equal to x times by my log natural 2. Well, now, because we ultimately care about the differential of all of this, I didn't differentiate here, but I am going to differentiate here. So if I differentiate the left-hand side with respect to x, I differentiate the right-hand side with respect to x as well. Well, by implicit differentiation, this is just going to become 1 over y dy by dx. And on our right-hand side, well, log natural 2 is just a constant. So this is the same as if I had differentiated 6x, I'd be left with 6. So differentiating log natural 2x, I'm going to be left with log natural 2. Okay, well, we want to find out what dy by dx is, so the best thing to do here would be to multiply both sides by y, so we're just left with dy by dx as the subject, so that's what we're going to do. And that's going to leave us with log natural 2 times by y. Well, y we know from the question was 2 to the power of x, so dy by dx of 2 to the power of x must be log natural 2 of 2 to the power of x. And that's just a rule to know for when you're differentiating, that if you differentiate some exponential function, some constant value to the power of x, then you're going to get the natural log of that value times by a to the power of x.